So for today, we will be having the continuation of my first video about the applications of algebra concerning word problems. First, we have their age problems, integer problems, and then translating mathematical English language to mathematical language. And for now, for today, we will be having variation problems, tips on how to solve it, or the mathematical statement concerning variations. We have here different cases concerning work problems. We also have analysis of mixture problems and some tips on rate problems. So let's start. So we have here variation. So variation is defined as the simple relationship involving one or more terms. So we have here, presented here, are three types of variation: the direct variation, inverse variation, and joint variation. So I also provided here a mathematical statement. So possible mathematical statement in which when you hear this, it refers to the specific variation. For example, y varies as x. So that refers to direct variation or direct proportionality. Another statement is y is proportional to x. Another is y varies directly as x. And also we have y is directly proportional to x. So in equation, y, it is equal to y, which is equal to kx. Wherein k is what we called our constant or proportionality constant. Next, we have here inverse variation. Y is inversely proportional to x, and then y varies inversely as x. Our keyword here is inversely. So since the statement says that y is inversely proportional to x, we have here y is equal to 1 over x. Multiplied by our proportionality constant k, our final equation is y is equal to k over x. And then we have joint variation. So we have here c varies jointly as x and y. As a reminder, so as a tip also, do not only rely with x, y, and z. So there are times na it can be ABC or RST. So do not rely or do not have this much confidence about studying variation specific with X, Y, and Z. So you must be ready with the appearance of other variables also. And then we have here, if Z varies jointly as X and Y, our equation will be Z is equal to xy multiplied again by our proportionality constant k. So if we have here z varies directly as x and inversely as y, we have here c is equal to k, our proportionality constant, and then directly as x, so we have here kx. And then final statement, we have inversely as y. So in simpler terms, our equation is z is equal to kx over y. So to visualize it further, I will be giving you a sample problem. As a sample problem, we have here, for variation, we have here, the question goes like this. If x is in indirect variation with square of y, and when x is 3 and y is 4, what is the value of x when y is 4? So if we think the problem is quite tricky, but we you can, by reading the problem, I can say that the final answer is 3. But here we will be going into the detail. We will be having details in particular solution. So first we have here the solution. So from the given problem, Indirect variation also means inverse. Indirect, so not direct. So that means inverse. Indirect variation equation can be expressed as x. So if x is indirect variation or inversely proportional or varies inversely as the square of y. So as I have said, it is not always xy. It can be another variable or a variable that is raised to squared, cube, like that. So in here we have indirect variation or inverse variation in which our variable is in squared. So our equation is equal to x is equal to k, our proportionality constant, over y squared. Or simply, you can put the denominator y squared into the other part of the equation. So we can have k, our proportionality constant, is equal to x y squared. So we have here our given case. First thing to do, if you have the given, you solve for the proportionality constant. And then use that proportionality constant to solve the new value of what is required. So for the given case, we have x is 3 and then y is 4. So to solve for k, which is xy squared, we have here 3 multiplied by 4 squared. So we have 3 times 16, that is 48. So now that we have the value of k, which is 48, and the question is, what is the value of x when y is 4? We already have the value of k, and then we are given with the value of y. We can now solve for the value of x. So since xy squared is equal to k, we have here x is equal to 48 over y squared, wherein y is equal to 4. So 4 squared is 16. 48 divided 16 is equal to 3. So we have here the value of x is 3. So that is our final answer. So next, for the application of algebra that we have here is work problems. So I will be providing you here 3 different cases in which this can be basis in making equations of work problems. So I hope this will help you. So first case, we have here total man hour to complete work is equal to sum of individual man hour. And then next, we have here sum of unit work is equal to total unit of work. And then case 3, we have here unit work multiplied by time is equal to unity. Don't worry, I will be discussing it one by one. For the case number 1, again, the governing formula is total man hour to complete the work is equal to the sum of individual man hour. So, again, this is not specific with hours only. It can be days. So, if you are referring to days, you can use man days or man hour. If we have man hour, we have man days. So that is number of men multiplied by the time in days. So as an example for this case, we have here 1,750 man hour excavate and backfill. So in excavating and backfilling, we have here 1,750 man hours. That is the total. So that is equal to, if we have 1,000 man hour excavating, so meaning the 750 man hour remaining belongs to backfill. So that represents the case 1, which is the total man hour to complete the work is equal to the sum of individual man hours. So next we have case 2. Case 2. This is the sum of unit work that is equal to total unit of work. So we have here 1 over TA plus 1 over TB plus 1 over TC and so on and so forth over 1 over TN or TZ is equal to 1 over X. Where in here, TA, TB, TC, TN, or any variable that you represent, that is the time that workers A, B, C, and N each can do the job alone. So, that is the time in which A, B, C, and N can do the job alone. So, that is for TA, TB, and TC. That time wherein they can do the job alone. And then X, so we have here 1 over X. The X here represents the total time that workers can finish the job if all of them combined working. So we have here TA, TB, TC, or TN. That is the time wherein they can do the job alone. So, and then we have here X. That is the time that the workers, for example, here A, B, C, and N, that is the time wherein they can finish the job if they are working together or they have this combined working. Next, we have case number 3. Unit work multiplied by time is equal to unity. So we have here 1 over T1 plus 1 over T2 plus 1 over T3 multiplied by TA. And then we have here 1 plus 1 over Tx plus 1 over Ty plus 1 over Tz multiplied by Tb is equal to 1. Wherein Ta is the time where 1, 2, and 3 work together. And then we have here Tb is the time where X, Y, Z work together. So to further visualize these cases, I will be providing one sample problem and then we'll be discovering what case it will fall on. Now we have here the sample problem for work. So the question states here, Peter, Paul, and Vincent decided to fence a vacant lot adjoining their property. So they are teaming up to come up with a certain work which is adjoining, fencing their properties. So if it would take Peter 3 days to build the fence, so that is 3 days for him working alone. And then Paul 4 days when he is working alone. And then we have here Vincent 6 days. How many days would it take them working together? So for our solution, first we will be thinking of what case will this problem, what is the most appropriate case for this problem. So the most appropriate case for this problem is case number 2. So the sum of unit work is equal to total unit of work. Why? Because we are provided here the unit work or the time. To be specific, we have here the days in which Peter, Paul, and Vincent can do the job alone. And the question is, how many days would it take them working together? So what is the time, or what is the how many number of days would it take them to finish the job when they are working together? So case 2 is the perfect case for this problem. So we have here 1 over time of Peter working alone plus 1 over time for Paul working alone, and then we have here 1 over Vincent while working alone is equal to 1 over X, wherein X is the number of days that would that is the number of days wherein they will finish the work by working together. So we only have to substitute 3 for Peter, for Paul, 6 for Vincent. So one tip here, we are in solving. So you can directly type this in the calculator and use shift solve. But then, if you also solve this as 1 over 3 plus 1 over 4 plus 1 over 6. Do not forget, others final answers are the 1 over x. Take note that we are finding for the value of the letter x only. So, if you are solving, solve for x, not for 1 over x. So, x is equal to 1.33 days. So, imagine, if they work together, so mathematically, this is an example na if you work together, so you can finish at a faster pace. So I hope this example enlighten you on how to use our cases or how to decide which cases are the most fit on your problems. So we now have here the mixture problems wherein two analyses are presented. The analysis 1, so that is quantity analysis. That is simply A plus B is equal to C. And then analysis 2, composition analysis. We have here AX plus BY is equal to CZ. So for the mixture problems, you can solve those problems by using this basis of analysis. And then in here, for the analysis 1, ABC represents quantities in which it may be in volume or in weight. So for analysis 2, we have here XY variables introduce XYZ, in which it can be in fractional parts, it can be in percentages, or it can be cost. So if you're talking value, there are sometimes for mixture problems, there are some questions which involve cost. So I will be providing you a sample problem. So here it is. So the mixture sample problem. So the question is, how many pounds of chocolate, so chocolate lovers, worth $1.20? So take note also, please be careful with the units because, of course, $1.20 is not directly equivalent to 1.2 pesos. So please take note of the units on your final answers. So the chocolate worth $1.2 a pound. The question is, how many pounds of chocolate, which is worth $1.2 a pound, must be mixed with 10 pounds of chocolate worth 90 cents a pound to produce a mixture worth $1 a pound? So a proper representation or a proper way to solve this problem, of course, first is to think of what analysis is better to use. So we have here, of course, the analysis 2 because we are provided with, with cost, which is also a part of, I mentioned just few minutes ago. So another also tip to solve mixture problem is to provide table of representation. So here we have Y, the amount of chocolate added. It is not, our variables are not restricted with XYZ. But I think that is the more convenient variables to use. So we have here 3 rows. We have cost, amount, and then you have to multiply the cost and amount because in analysis 2, we have the equation AX, and then you have to multiply A with X, B with Y, and then C with Z. So for the original, we have the cost, which is 0.9 because that is 90 cents. So again, you have to know the different units of money. We have pound, quarter, cents. um, dollars, penny, and also the different money used by yung common lang. For example, in the Philippines, we have peso and then US dollars, Canadian dollars. So let's proceed to the solution. So we have here the original cost is 90 cents a pound. And then we have here for that cost 10 pounds. So as you can see in the given, we have here 10 pounds of chocolate worth 90 cents a pound. So as you can see, that is in the original. And then we have here, the question is, how many pounds of chocolate worth $1.2 a pound must be mixed? So the code or the term must be mixed represents addition. So what what is the amount of chocolate that we need? So we are given with the cost, which is $1.2. But then the question is what exact pounds or how many pounds of chocolate that we need. So that is that we in here we represent it as Y. And then the result, of course, is in the cost that is in the given, that is $1 a pound. And then for the amount, if we have the original having 10 pounds and then we will be adding Y amount of chocolate, which is initially we don't know. So our resulting amount of chocolates in pound is 10 plus Y. So that is why this ideal solving of mixture sample problems or mixture problems is to provide tables. So we have here by multiplying the original, which is 0.9 by 10, that is 9. And then added, we have 1.2y. And then we have here the result, which is 1 multiplied by 10 plus y, or simply 10 plus y. We have here 9 plus 1.2y, which is equal to 10 plus y. So by simultaneously solving this, we will be having 1.2y minus y because we transpose y to the other side and then 9 to the other side of the equation. We have here 0.2y is equal to 1. So y is equal to 1 over 0.2, which is equal to 5. So our answer again is 5 pounds of the $1.2 chocolate. That is the amount needed to be added to the 10 pounds of chocolate worth 90 cents to produce a mixture worth $1 a pound. So you have to be specific with your answers for mixture problems. So this is just few reminders for the rate problems. This is our last for our content for today. So for rate problems or motion problems in algebra, this is usually classified as uniform motion. Usually no acceleration is involved. Thus, the only equation involved is S is equal to Vt, wherein the distance is the letter S. So it's okay if you use letter D. Other books are using the letter D. And then we have rate, which is V, or velocity multiplied by the time T. So that's it for simple introduction or brief description of what rate problems is all about. I hope I was able to help you about rate problems, variation problems, and then work problems, and then mixture problems. So yes, if you wish to have a copy of this PowerPoint presentation, and if you also have some questions regarding the topic, word problems, kindly email me at ryannicole05@gmail.com. Please don't forget to subscribe. Thank you!